Alright, ladies and gentlemen, in this video we are diving on into complex numbers. Now I'll admit, when it came down to synthetic division, long division, I'm not overly thrilled about them, but I can't say the same for complex numbers. I love them. It's fun. It's different. It's almost like you're like diving into a different universe of numbers, and it's like we always don't think that these things exist, but there actually is great purpose and use for them, and so it kind of gets a little bit exciting to deal with an imaginary unit that we normally don't get to see on an everyday basis. So let's take a look here. Our goals are to use that imaginary unit I to write complex numbers, how to use complex conjugates to write the quotient of two complex numbers, and throughout this section we are going to find complex solutions of quadratic equations. So I have a very basic question for you just as we start some things on up here. And the question just simply states, hey, solve for x squared plus 1 equals 0. All right, well, let's go ahead and see what happens. Well, the first thing we would normally do is we would just subtract 1 on both sides. X squared equals negative 1. According to this, we know the opposite of squaring something is rooting it, so we'll square root. But wait, we can't take a square root of a negative. That's a problem. That's a problem right in there. However, because of our imaginary unit, it is true that we do have a way to overcome such a, I guess, mathematical deficiency in an example like this, in which we have described that, hey, I is equal to the square root of negative 1. All right? What does that mean? Well, that also means that I squared equals negative 1. Another super important part to take into account. All right, that's exactly what we're diving on into, guys. I is equal to the square root of negative 1, thus I squared equals negative 1 itself. The addition of real numbers to imaginary numbers, guys, makes up what we call the set of complex numbers. I'll say it one more time. The addition of real numbers to imaginary numbers makes up the set of complex numbers. So what does standard form look like? What do you guys think? Think about what the definition says. The addition of real numbers to imaginary numbers. Well, what's a real number look like? I don't know. We can call it anything you want. A, B, C, D, Q, R, S, right? What's an imaginary number look like? Well, anything being multiplied by I, the imaginary unit. So that's where we get our standard form. A plus B, I. All right. So let's utilize that a little bit. Let's do some basic product finding of two different complex numbers. So what do we got here for part A? So it's just two basic binomials. We're going to go ahead and look at part A of 2 minus I times 4 plus 3I. Well, let's distribute, FOIL it on out. We got 2 times 4, which is 8. We've got 2 times 3i, which is 6i. Negative I, that's minus 4i. And then we end up having a negative 3 times I squared. All right, well, 8i plus 6 minus 4 is 2, so 2i. But however, what did I tell you that I squared equaled? What was I squared? Well, don't forget, guys, I squared has value. I squared is a negative 1, right? I squared is, in fact, a negative 1. So what does that actually look like for this particular purpose here? Well, if I squared is negative 1 and negative 3 is negative, that's actually a positive. So what's our, in standard form, we're looking at 11 plus 2i, right? 11 plus 2i. All right, well, what about part B? Let's give B a shot. So for part B, once again, we have 3 plus 2i. 3 minus 2i. So 3 times 3 is 9. 3 times a negative 2 is a negative 6i. Plus 2i, that's a positive 6i. And then a negative 4i squared. Boom, cancel, cancel. 9 minus, or in this case, we end up having a negative 1 times a negative 4. So we have another positive happening in here for a positive 4. Thus the standard form that we have there is just 13. Okay? So there's kind of a refresher course on what it means to multiply complex numbers together. Again, the key thing to understand is that when you get an I squared on in there, I squared ends up giving us a negative 1. All right, guys, that's going to wrap it on up for this video. On to our next one. We're going to look at two complex conjugates.